Good morning, students. So today we are starting with the second unit of operation research, and in that the topic of explanation is the assignment models. So the assignment models are the special optimization technique as compared to the transformation and simplex method of optimization techniques. So these special type of techniques are basically used to reduce the computational work as required by the simplex and transformation techniques. So in assignment problems, it finds many applications in allocation and scheduling. So for example, in assigning salesmen to different regions, vehicles and drivers to different routes, products to factories, jobs to machines, contracts to bidders, and research problems to the teams. So an assignment problem mainly concerns as to what happened to effectiveness function when we associate each number of origins with each of the same number of destinations. So the table represents n facilities to n jobs, and Cij is the cost of assigning ith facility to the jth job, and Xij represents the assignment of ith facility to jth job. If ith facility can be assigned to jth job, then Xij equals to 1, otherwise it is 0. So you can see in the table, so this are the number of jobs 1 to n. Now these are the number of facilities that are available from 1 to n. So each facility is assigned to one of the jobs. So this is called as assignment, and you can see the C11, C12 up to C1n. Similarly, C21, C31 and up to Cnn are the cost of assignments that are associated. And always you remember, the objective is to make assignments that minimizes the total assignment cost or maximizes the total associated gain. So if I want to write the mathematical representation of the assignment model, so it is, if Xij equals to 0 if the nth facility is not assigned to the jth job, and Xij equals to 1 if the ith facility is assigned to the jth job. Then the model is given by minimize z is equals to summation j to 1 to n, summation I is equals to 1 to n, Cij into Xij, subject to constraints. Summation of Xij, j is equals to 1 to n is equals to 1, and I is equals to 1 to n. One job is assigned to the ith facility, and summation Xij equals to 1, and I is from 1 to n, comma j is equals to 1, comma 2, comma up to 3. One facility is assigned to the jth job. So this is basically a simple mathematical model. You can just see in the equation. So you'll understand in much more detail when we solve few numericals based on assignment models. So we'll start with one of the numerical, and how to solve that particular assignment model by using one efficient technique of optimization, or it is called as Hungarian method of assignment. So we'll start with the numerical based on assignment models. So I'll read out the problem definition. A machine tool company decides to make 4 sub-assemblies through 4 contractors. Each contractor is to receive only one sub-assembly. The cost of each sub-assembly is determined by the bids submitted by each contractor and is as shown in the table in hundreds of rupees. So determine the different sub-assemblies assignment to the contractor so as to minimize the total assignment cost. So this is the given problem. So step 1, subtract minimum element from each rows, which results in the matrix as given below. So now I'll identify the minimum element of each row and subtract that minimum element from all the elements of each row. So for the first row, if you just see what is the minimum element, it is 13. So subtract this minimum